Hello viewers, Wagadaruna taking you through the story of A-level pure mathematics, and this video we're going to go through the senior 5 marking guide of end of term 1 of 2022 in one of the schools where I happen to be a teacher. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So question 1 said, express the following in the form a plus b root 2, Roman 1 and Roman 2. So just start with Roman 1. Roman 1 is the quotient, meaning you have to rationalize. So when I multiply up and down by 3 plus root 2, I'll come up with this in the denominator and this in the numerator. Then I expand this, I'll come up with this, expand this, come up with this. And then I'll split the numerator, because this is 7 split the numerator, it became 11 over 7 and 6 root 2 over 7. And that's what they wanted. Then part B, I have to open brackets, so this times this, 15, this times this is that, and this times this is this, and this times this is that. So simplify, we'll come up with 13 plus 2 root 2, and that's what they wanted. Then question 2 says, solve the equation this. So there we shall first of all, this one is the same as 2x to the power 2 times 2 to the power 8. So from there, I'll come and say that let y be equal to 2 to the power x. So I'll come and substitute. So 2 to the power 8 is 256, and this one becomes y squared. This one becomes 32y plus 1 equal to 0. So this is a quadratic. I can solve it, and I'll be able to come up with y as 1 over 16. So it has repeated roots. But I know that y is equal to 2 to the power x, therefore 2 to the power x is equal to 2 to the power negative 4, because 1 over 16 is 2 to the power negative 4. So when I cancel this, I'll come up with x equal to negative 4. And that's what they wanted. Then question 3 says, find the equations of the tangents and normal, tangent and normal to the curve, this at a point where x is equal to negative 2. So the first thing to do is to get the gradient function by differentiation. So when I differentiate this, I'll come up with this, differentiate this, I'll come up with this, and differentiate this, I'll come up with 0. Then I remember that at x equal to 2, y will be equal to 16 when I substitute. Therefore, the gradient of the tangent will be got by substituting for x. By that, x is substituted at this point to give you negative 13 as the gradient. Therefore, the equation of the tangent will be got by changing y over changing x. So changing y will be y minus 16, changing x will be x minus negative 2, which is x plus 2, equal to the gradient, which is negative 13. Cross multiply and correct like terms to come up with this as the gradient equation of the tangent. What about for the normal? Gradient of the normal will be negative 1 over gradient of the tangent to give you 1 over 13. Therefore, equation of the normal will be got by changing y over changing x, cross multiply, and rearrange. So that is what they wanted in question 3. Then question 4 part A says, express log this in terms of this, this, and that. So let's start with that. So log this is the same as the numerator is this, which is log 100 plus log a squared. Denominator is this, so we must use this bracket. They are very vital. So log 100 is equal to 2, because it is 2 log 10 squared. It is log 10 squared, which is 2 log 10, and log 10 is 1, so we remain with only 2. Then here this one comes this side to come up with this, and here this 3 comes this side to come up with this, and here this side comes up here to come up with this. So there's a negative because of this bracket. So that was part A. Part B says, given that log 5 is equal to this, find the value of log 40 correct to 6 decimal places. So log 40 is the same as 1000 divided by 25. 1000 is 10 to the power 3, 25 is 5 squared. That means that this one goes this side to become 3, and log 10 is 1, so it remains 3 alone. This one goes this side to come up with 2 log 5. Then you substitute for log 5 to come up with this to 6 decimal places. Then question 5 says solve simultaneous equations, this and that. So from this first one, 25 is the same as 5 squared, so it becomes 5 to the power 4y, because 2 times 2y becomes 4y. Therefore, when I add, these are same base, so you add the powers to become 5 to the power x plus 4y. And here 1 is the same as 5 to the power 0. Therefore, x plus 4y is equal to 0, implying that x is equal to negative 4y. So that was from the first equation. What about from this equation? From here we shall see that 1 over 9 is the same as 3 to the power negative 2. Therefore, 5x plus 2y is equal to negative 2. But the good thing, x is equal to negative 4y, so I'll substitute for x and make y the subject. Then come and substitute for y here to get the value of x, and that's what they wanted. Then question 6 says, given that this and this are factors of the quadratic this, find the values of a and b. So it is a factor, the remainder is 0. Therefore, fx let it be equal to that function. So for this and this to be factors, this and this will be roots. Therefore, f3 will be equal by substituting where there is x, we put there 3 and equate to 0. You will come up with an equation. Then f negative 7, where there is x, put there negative 7. Simplify and you come up with an equation. So there are 2 equations and 2 unknowns, therefore solve them simultaneously. So when I subtract this 49 minus 9a, I come up with 40a, b and b cancels. Then 84 minus negative 136 gives you 120. So make a the subject and a will be 3. From equation 1, I'll be able to substitute for a and come up with the value of b. And that's what they wanted. Then question 7, if the expression this, and this have a common factor, determine the possible values of n. So let x minus alpha be the common factor. So it implies that here, where there is x, we keep on putting alpha to come up with equation 1. Also here, where there is x, put on alpha to come up with that. I think we realize that when you substitute the root, we equate to 0. Here it was not equal to 0, but now it is equal to 0. Even here, substitute the root and equate to 0, because it is a factor. Then from there, we'll come and solve them simultaneously. So the first thing to do will be to get the value of alpha. So this equation 1 times equation times 3 minus equation 2 times 2 gives you that. So subtracting this cancels, this minus this gives you positive 13 alpha. This minus this gives you negative 26 equal to 0. Therefore, alpha is equal to 2. After getting alpha, I will come back here in equation 3 and substitute for alpha and look for getting a value of n, and n will be 3. So that is what they wanted. Then question 8, if alpha and beta are roots of the equation this, form an equation with integral coefficients whose roots are this. So from the given equation, sum of roots, first make this quotient 1 to give you that, therefore sum of roots will be 5/2 and product will be -1/2. Now for the required equation, sum of roots will be got by adding these two, get LCM to come up with this. Then this numerator is the same as this. I think by now you know it. Then from there we substitute sum product to give you 29 as the sum of roots. Then product of roots will multiply and substitute this product to give you 4 as the product of roots. Therefore the required equation will be given in this form, so this is sum, not n, sum. So substitute and that will be the equation they wanted. Then question 9, part A says, show that the expression this is 0 when x is equal to 3/2, and hence factorize the expression. So it means that let fx be equal to that expression. Therefore, when I substitute for x equal to 2/3, this is what I'll get, and I'll end up with 0, meaning I have already shown. But they told us to factorize. So now we have known that this is a root of this expression. Therefore, in factorizing, I'll divide. So this one, where is it coming from? Remember, it was x equal to 2/3. So when I cross multiply, I'll come up with 3x equal to 2. Then when I take it this side, I'll come up with 3x minus 2, which is here, which is a factor. So this is the equation they give us, so I have to long divide. So this divided by this, I'll come up with x squared. Now x squared times the whole of this, I'll come up with 3x cubed minus 2x squared. Then I have to subtract the 2. When I subtract, I'll come up with, this cancels, I'll come up with 3x squared minus 8x plus 4. Then divide by this, I'll come up with x times the whole of this gives you that, subtract to come up with that. So again divide, -6x divided by 3x, I'll come up with -2. -2 times the whole of this gives you that. So when I subtract, to be 0. That means that the whole of this function is equal to this, which is here, times this divisor times this quotient, which is here. When I factorize this one, I'll come up with this, and that's what they wanted. Then for part B, they said find the values of s, find the values of m for which the equation this has equal roots, and then for what value of m is the sum equal to 0, sum of roots equal to 0. So for equal roots, discriminant is equal to 0. Therefore substitute b squared equal to 4a is 1 and c is 4m. Simplify to come up with a quadratic, solve it by either factorization or bulldozer method to come up with 2 values of m. Therefore the sum of roots equal to 0, it implies that this is equal to 0. Therefore m will be -3, and that's what they wanted. Then question 10 part A says differentiate this with respect to x from first principles. So let y be equal to that, the given expression. Then small change in this one will be the small change in y when x is incremented by small change in x. That means that when I put small change in y here, I also have to add small change in x here and here. Then expand this to come up with this. Then from there, I remember that y is equal to this, so this y will go with this and that to remain with small change in y, this, and that. Then dividing through by small change in x, I'll come up with this. So this one cancels to remain with 2x. This one square cancels to remain with small change in x. This one cancels to remain with 2. Therefore, y dx will be the limit of small change in x, small change in y, small change in x, for small change in x tending to 0. So this means that where there is small change in x, I'll put there 0 to remain with 2x plus 2 as the answer they wanted. Then part B says, find the equations of the tangents to the curve this, which are parallel to the line this. So parallel lines have the same gradients. So this is the curve. I have to first get the gradient function by differentiating, but I know that the gradient is equal to 3. So I come and equate to 3 and get a quadratic, solve it, get the values of x. So I have to get the corresponding values of y. When x is 3, y is 11. Therefore, the equation of the tangent at this point will be given by change in y over change in x equal to 3. Cross multiply and rearrange. Then when x is equal to 1, y will be 9. Therefore, the equation of the tangent at this point will be given by change in y over change in x equal to 3. Cross multiply and rearrange. And that's what they wanted. Then question 11 says, part A, find and classify the turning points of the curve this, hence sketch the curve. So we have y, then we shall differentiate. Then remember that at turning points, dy dx is equal to 0. So I'll come and equate this dy dx equal to 0 and solve the quadratic to get the two values of x. Then I have to get the corresponding values of y. When x is 1, y is 0. And when x is negative 2, y is 27. Therefore, the turning points are these ones. So we have got the turning points, but we have to classify them. Which one is maximum, which one is minimum. So I'll come here and say that the second derivative, this is the first derivative, second derivative will be this. Therefore, at this point, the second derivative will be positive. Because it is positive, it will be a minimum point. Then at this point, second derivative is negative. And because it is negative, it will be a maximum point. So there we have classified. Then the intercepts, what happens when x is 0? When x is 0, y is 7. Therefore, the point, this is also but we also know, so this is one intercept, which is 0, 7. But we also know from this, from the previous slide, if you go back here, we got 1, 0, meaning that it's also an intercept. Now, because it is an intercept, it means we have already got one intercept. Therefore, by synthetic method, we shall be able to factorize our cubic equation. So how do we factorize? Factorizing can be by synthetic or by long division. So you already saw long division. Now I want to show you the method of synthetic. But all these methods are available on this platform because we already made a video on sum and roots of a quadratic equation. So what you do for synthetic, write the coefficients 2, 3, negative 12, 7. Then from there I come and write here the root x equal to 1. Then what you do, bring this one down and multiply this times this to give you 2, and that's what you write here. Then you repeat the procedure. This plus this gives you 5. 5 times this gives you 5. Repeat the procedure. This plus this gives you -7. -7 times 1 gives you -7. Then this plus this gives you 0. So what is put here, it will be the remainder, so the remainder is 0. Therefore y will be equal to this factor which comes from this root, and then this one, how is it got? This is the quotient of x squared, quotient of x constant. When I factorize this, I'll come up with this. Therefore when y is 0, it means that the whole of this is 0, implying that x is equal to 1 or x is equal to -7/2. Therefore the intercepts are the 0, 7, 1, 0 and -7/2, 0. So I've got the intercepts, I've got the turning points, therefore I can sketch. So in summary, those are the intercepts and those are the turning points. Therefore the sketch, I have to draw the axes and label them x-axis and y-axis. Then I'll have to put the intercepts. There is 7, 0, there is this one, there is this one, and there is this one. Then I also have to locate the turning points. So there is this turning point which is -2, 27, and also this turning point. Then I have to remember that this one is maxima and this one is minima. Therefore when I'm drawing it, the shape should come out. And the curve has to be labeled, and that is what they wanted. Then for part B, they said an open tank is to be constructed with a square base and vertical sides so as to contain 500 meters cubed of water. What must be the dimensions if the area of the sheet metal used in its construction is to be minimized? So they said open tank and the volume is 500. So volume will be length times width times height to give you 500. Therefore h is equal to that. What about for an open tank? The total surface area will be that. It will be, remember, so this is x, and this is also x, and this is h. So open tank means this upper part does not have metal, it is just open. So this one is only we shall only take the bottom part, which is x times x, which is x squared. Then for this other side, there is this side, there is this side, there is the behind side, and this side. So that is why we put 4x times h. Then you substitute for h and simplify, then differentiate. After differentiating, you remember that minimizing derivative must be equal to 0. So equate to 0 and make x the subject. So x will be equal to 10 meters. Therefore from this equation I can be able to get the value of h, and those will be the dimensions they wanted. Then question 12, part A says, find the equation of a straight line whose gradient is this and passes through point this. So equation will be change in y over change in x equal to the gradient. Then cross multiply and simplify. So that's what they wanted. Then part B, Part B, find the equations of the lines which pass through the point of intersection of the line this and this, and are respectively parallel and perpendicular to this line. So when I simplify, I can get this, it is also okay. Or you stop here, it is also okay. So first of all, these two lines are going to intersect at a certain point. So at the point of intersection, how do we get the point of intersection of two lines? We solve them simultaneously. So you shall come and get for this line, then from this line you shall substitute for x and make y the subject. So y is equal to -1, therefore come here and substitute for y and get the value of x. So that will be the point of intersection. So they have told us they want equations of lines which pass through the point of intersection, so I got the point of intersection, and are parallel and perpendicular to this line. So the first line will be parallel to this, and second line will be perpendicular to that. So for the line parallel to this, gradient is equal to that. Therefore, you have the gradient of a point, so you can get the equation, cross multiply and rearrange. Then for the line perpendicular, it means that gradient will be positive. Why? Because it will be negative of -1 divided by this to give you 4/3. So substitute, cross multiply and rearrange, and that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on marking guide for senior 5 of math part 2 of end of term 1. So if you're not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.